Hello, this is John from caveofprogramming.com, and this is a tutorial on the static keyword in Java. So I'm in Eclipse and I've got my main program here, and I'm going to start by creating a class up here which I'll call thing, and I'm going to give thing two member variables. I'll make them both public, and let's give this a name variable of type string, and I'll also give it another variable of type string called description. Now description I'm going to make static, so before the string type here I'm going to put the keyword static, and we'll have a look at what the difference is between this and this. So if I, oh, and by the way, I should mention that usually if you have member variables, most of the time you declare them private or protected, which we'll look at later in this series of tutorials. But just for this tutorial, I'm going to make them public to keep things simpler. So I'm going to declare a couple of thing objects here. So let's have thing1 equals new thing, and I'll have a thing2 equals new thing. Now with the name variable here, each thing object has its own copy of name, so I can set thing1.name equal to Bob and thing2.name equal to Sue, and of course I can display those with a sysout. So let's say thing1.name and sysout control space thing2.name, and of course if I run this it's going to say Bob and Sue. The difference with the static member variable here is that each object does not get its own copy. Static member variables, also known as class variables, belong to the class, and there is only one copy because there's only one class. So if I want to access description, I access it via the class. I type the class name, description equals I am a thing, and I can do sysout on that in the same way, thing.description. So variables like this, which aren't static, are called instance variables, because every separate instance or example, or in other words, every separate object of the type thing gets its own copy. Whereas static variables like this are often known as class variables because they are associated with the class. So if I run this, you'll see down here it says I am a thing. And let's also have a look at static methods versus instance methods, because if I create here a public show name, let's say, I can do in here sysout name, and so I'm just outputting the name using this instance method, and I can replace my sysouts down here with a call to thing1.show name, and I should put the return type here, void, and thing2.show name like this. So if I run that, it's just going to do the same as before. I'm just calling these methods to output the name for each object. Now, as you might suspect, with a static variable, let's just maximize the editor here, Control M in Eclipse. With a static method, you can access it via the class. So if I write public static void, let's say I'll call it show info, then I'll just do a sysout in here, and I will put hello just for the moment. So to run this show info, I just say thing, the class name in this case, dot show info, like that. So I'm accessing it via the class. And let's get rid of this sysout. and if I run this now, it's going to output hello. So I'm running this static method here via the class. Now there are a couple of things to bear in mind here. One thing is that static methods can access static data because both belong to the class. So if I say in here, if I output description, the static variable in my static method, that's going to work. So this is going to say I am a thing, just from calling my static method here. But static methods can't output instance variables like name. This gives me an error which says cannot make a static reference to the non-static field name. And that makes sense if you think about it, because the static data, the static instance variables exist before you've even created any objects from your class. So how can this know about the name which is associated with particular objects? It can't. So let's just put won't work. On the other hand, the instance variables can access the static data because, the instance methods can access the static data because, of course, by the time you've got objects, of course, you've already got the class. So methods attached to the objects naturally can access data attached to the class. So in this show name, which is an instance method, a normal sort of method, I can output description here. So let's just put a plus in there and some punctuation. And if I run this, I'm going to get, so this is from the static method here, I am a thing, and the instance methods are outputting I am a thing Bob, I am a thing Sue. So the instance methods can access the static data. Now, you might be wondering what you can use static for, and there are several uses that spring to my mind, and I'll show you some of those here. Of course, one use is that if you've got a method that takes some arguments and outputs some data, but never deals with the instance data of the class, then you could make it static, because you only need really instance methods if they somehow deal with the instance data of the class. But there are a few other interesting uses as well. So let's say let's have a look at one typical use of static, which you can find in many places in Java, but a good example is the math.class. It's a standard part of the Java library, and the math.class has constants attached to it, for example pi. So if I output math.pi, you can see that I'm accessing a variable here, well, a constant actually. I'm accessing some data via the class math, which might lead you to suspect correctly that it's static. So if I run that, here we get pi being output down here, just from this. So let's see how we can make our own constant in the same way. So here, if I want a constant, so the kind of thing that I want to achieve is I want to be able to say something like the name of my class, which is thing dot, let's say, I don't know, thing dot lucky number, or this could be a string, sorry, lucky number, or whatever you like. Now see, pi is a constant, which means I can't reassign it. I can't do math.pi equals 3. If I save that, let's comment this out as well. So this will give me an error. the final field math.py cannot be assigned. It's constant, meaning it's unchangeable. And constant values, kind of by tradition or convention in Java, are represented by uppercase letters, and that's why I've written this in uppercase. And just to make it more readable, I've put an underscore in the middle there. And to implement that, so it's going to be a public variable, public because it's accessed outside the class, and we're going to look at public, protected and private in future tutorials. And I'm going to make it of type int, although it could be anything you like. Int, and I'm going to call it lucky number, like this. And I'm going to make it, I want to access it via the class thing.luckynumber, so it's going to be static, so public static int. And I'm also going to declare it final, so I'm going to put the final keyword in here. And final is Java's version of constant, and that just ensures that you can't reassign a value to this. And if you have a final field, you've got to assign a value to it when you create it. So here I need to write equals, and then let's just set it equal to 7, because after you've created the variable, you will no longer be able to assign a new value to it because it's final, it's constant. So you can see that this will now work, and if I run that, it's going to say 7 down here. So I've just got this constant value, which, as I say, could be a string or whatever, that's attached to my class. And you see that all over the place in Java, like in the color class in string, or jframe.exit on close, and math constants, and it's absolutely all over the place. Another really good use of static is to count the number of objects that you are creating. So let's have in here just for simplicity, I'll make it public again, but normally this would be private and you'd access it via a getter, but I'll say public int count, and I'm going to make that static, so it's attached to the class, not to the particular objects. And I'm going to initialize it to the value 0. And I'll give thing a constructor. So I'll say public thing, no return type for the constructor. Now this constructor will be run every time you create an instance of thing. In other words, whenever you do new thing, it's going to run whatever code I put in here. So I could take that opportunity to increment count. And because count is static, it belongs to the class, not to the objects. And that means that there is only one count, which is shared between all objects. So anytime an object increments count, there's only going to be one copy of count, and it's incremented for all objects in effect, because, as I say, it's attached to the class. So here I've done, well, let's first of all output it up here. I'll say sysout thing.count, and as I say, normally you'd have a getter called getCount probably, and then let's say here I'll just put some text in and say before creating objects, count is like this, and I'll put a plus in there. And let's just copy that, and I'll move it down here after I've created my objects. So if I run this, it's going to say, scroll up a bit, before creating objects, count is 0, because when I output thing.count up here, it's just at its initial value of 0. But every time I create an object, it runs the constructor and increments count. So after I've created my objects here, each one of those will increment count. And then I'm outputting thing.count again. and it's saying after creating objects, count is 2. So this is handily counting the number of objects that I've got. And that brings me to one final interesting use of count, which is assigning an ID to each of your objects, a unique ID. Because supposing here I create a instance variable, not a class, not a static variable, but an instance variable, and I'll call it public int ID. And just to repeat, these shouldn't really all be public, but they should be private or protected, but this will do for this tutorial. And I won't initialize ID here. Actually, your instance variables in Java are initialized to default values, so this will be 0 anyway to start with, but that doesn't matter. I want ID to be unique for each object. So the first object should have ID, let's say 0, and the second object ID 1, and so on. And all I have to do to get that to work is I can assign the value of ID, and every object has its own ID because it's not static, it's an instance variable. So I can assign that to the static variable count, and the static variable count being shared between all objects is of course incremented every time you create an object, but this will keep a kind of record of whatever count was at the time the constructor ran for each object. Each object has its own ID, but there's only one shared count. So that means that if I say down here, let's say, I could change show name. So in my show name method here, I could say object ID and plus, and let's add on ID, and but I'll have some punctuation in here and a space, and then I'll have the ID, and then some more space or punctuation like this. So show name now, didn't mean to do that. Show name now is outputting the ID for each object as well as its name. And if I run that, so show name is running down here. If I run this program, it's saying object ID 0, I am a thing, there's the static description, and instance data again, Bob. And second object ID 1, again instance data, I am a thing, static data, and then the name Sue, which is instance data. It's quite a lot to take in for one tutorial, but I'm going to put this code on caveofprogramming.com, which is all one word, so you can take a look at your leisure if you want to. And the approach I always take myself to learning this kind of stuff is just basically use it, copy it and paste it in and get it to work. And after a while, you sort of start to get a feel for it. And if it seems at all obscure now, after just using it and working with it a bit, you'll start to see that it's pretty simple, really. It's not too bad. So that's it for this tutorial. In the next tutorial, we're going to look at string builder, string buffer, and some advanced string formatting, which we'll need before we go on to some more stuff to do with objects. So join me again then, and until then, happy coding.